Welcome to lesson 9. Today we're going to be writing equations for proportional relationships. So the big question then is, how can we use what we know about the constant of proportionality, which is just a really fancy way of saying rate of change, okay, to write an equation. Okay? And that's what we'll be focusing on. So the last couple of days you've been talking about rate of change, and that's going to be the focus of writing equations today. So some points to remember, right? Proportional relationships have a constant ratio or a unit rate. They both should be constant. They shouldn't change. If they do change, what we're learning today won't work. You cannot write an equation unless it has a constant rate of change or a unit rate. Okay. So sometimes known as a constant ratio or a unit rate. The other really fancy name they sometimes use is constant of proportionality. You may see that in directions. If you do, it's talking about the same thing, constant rate of change. Okay, so all these ways are just fancy ways of talking about how does the rate change in a question, whether it's a graph, whether it's a table, whether it's a word problem. That's going to be our big focus again, and we're just going to create an equation out of it. So we're going to first look at a question you saw back in lesson 8 when we were talking about cars being washed, right? So this one should look very familiar, and we actually found the constant rate of change for this, so this should be a review. So the first thing we always got to do, right? Constant rate of change is change in y over change in x, right? I don't want to write with such thick lines, okay? And to do that, we got to decide which one's independent and dependent first, right? So if you're washing cars, the one thing you can control is how many cars you wash. That's going to be our x value, right? That's our independent value. That's what we control. X was independent. Leaving the money we make as our y value, our dependent event. Okay? So once you decide that, then you know what numbers can go on top and bottom, right? And to do that, we're just going to see how does the y change. The y changes from 40 to 80. That's a change of 40. And if we keep checking it, they're always changing by 40, which is kind of nice for us. If we check the other side, 5 to 10 is a change of 5, 10 to 15 is a change of 5, and 15 to 20 is a change of 5. So they're all changing by the same amount. And what makes this nice is then when we compare these, right? And when we compare these, we're comparing this one with this one and this one with this one, right? And we can kind of see that they're all the same. They're all going to be 40 over 5. So over here we have $40 over 5 cars as our rate of change. And it is constant because it's always the same. If we reduce this, it's going to be 8 over 1, right? So this is our rate of change, ROC, right? Rate of change. So with that information, right? That's what we did in lesson 8, in both parts of lesson 8, right? Now we're just going to take that and we're going to create an equation. And our equation is pretty straightforward. It's just right down here, okay? It's y equals your rate of change times x. And there should be maybe a little dot there to tell it's times x. So our answer for this one is just going to be y equals, and our rate of change, right, was over here to the right. ROC was 8. So rate of change is 8 times x. This is our equation, right? Pretty straightforward. Y equals the rate of change times x. So if we look at this equation, what it tells us is, and again, the y stands for money, right? So this is the money equals 8 times the number of cars we wash. So if I just do 8 times how many cars I washed, I figure out how much money I made, and that's exactly what this table is telling us. Okay. So again, if it helps, right? That stands for the money. That stands for $8 per car, and this one is the number of cars. That's what each part of our equation stands for. Okay. All right, let's go on to the next question. We'll take this next one a little further after we find the rate of change in the equation. So example 1, do we have enough gas to make it to the gas station? Okay, your mother is beginning a long road trip and you notice that the low fuel light is on, indicating that there is a ½ gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a gas log where she records the gas and the number of gallons purchased each time she fills up the tank. So here's her record, right? First question is this a proportional relationship, right? So to do that, we just got to see, is it a constant rate? right? Is it a constant rate? And does it go through 0, 0, right? It's got to do two things. We learned that when we were graphing things, right? So let's decide if it's a constant rate first. Well, this side's going up by 2 and then by 2. And this side, if we use a calculator and go 168 minus 112, it turns out to be 56. And if we use a calculator here, 224 minus 168 is also 56. So I think we can see, right, going over here, our change in y over our change in x. Ooh, and actually we don't know which one y and x is yet, right? Which one are we controlling? Well, or what has to happen first, right? Well, gallons happens first. So that's our x value. And then the miles is our y value. So our x was 2. Our y was 56. And that reduces down to 28 over 1, right? And that's our rate of change. So it does have a rate of change, but that's not enough. It doesn't have to just have a constant rate of change. It also has to go through 0, 0. So if I extended this a little bit, right, I'm at 4. And if I continue to go by 2s, this would go back to 2. And if this changed by 56, I'd go back to 56. If I go back one more time by 2, I end up at 0. If I go back by 56 again, right, 56 minus 56 gets me to 0. And look at that, 0, 0. So is this a proportional relationship? Yes, because it's a constant rate, which we found, right? We found it's 28 over 1. And it goes through the origin, 0, 0, which we did by extending our table. Okay. So let's see if we can answer some questions down here. Find the constant rate of change and explain what it represents in this situation. Actually, we just did that, right? It was change in y over change in x. And we found out it was changing by 56 over 2, right? Which reduces down to 28 over 1. Again, I just got that right from here, right? But what does it stand for, right? What does it represent? That was part of the question. And that really just comes down to labeling, right? Our y value up here was miles driven, right? Y was miles driven. So this is miles. And our x was gallons. So if I wrote a sentence about this, it would just be, Mom gets 28 miles per gallon. I added the context to the question. Mom's driving her car, and she gets 28 miles per gallon. That comes straight from the rate of change. All right, part B, write the equation. All right, well, our basic equation is always y equals the rate of change, right, times x. Well, we found the rate of change in part A. It's just y equals 28 times x. There's our equation, right? Just sub in that rate of change. It was 28 over 1. All right, part C. Knowing that there's a half gallon left in the tank when the light comes on, will she make it to the nearest gas station? So all we need to really do is use our equation, right? And sub in that half gallon. So does the half gallon go in for the y or the x? And if you're not sure, go back to our labeling. This is why we labeled. Which one was gallons? If we go back up here, look, x was gallons, right? So I'm going to sub in that half for my x. So y equals 28x. I'm going to take the x out, and I'm going to sub in my 1/2, and then I can see what happens, right? 28 times a half turns out to be 14 miles. So with a half gallon of gas, we can go 14 miles. Will Mom make it to the gas station? Well, we have to go back up. How far was it to the gas station? The nearest gas station is 26 miles away, right? Well, she only has a half gallon, which will get her 14 miles. Is she going to make it? No, Mom's going to get stranded, right? She can only go 14 miles. She needs 26 miles, right? All right, part D. Using that equation again in part B. So our equation in part B was y equals 28x, right? Determine how far your mother can travel on 18 gallons of gas. And again, we just said gallons of gas was our x value. So all we're doing is we're subbing in the 18 gallons of gas into X. And then we get out our calculators. 28 times 18 is 504 miles. So she filled up her tank all the way up to 18 gallons of gas and just drove. She's going to get 504 miles before she runs out of gas. Okay. All right, next page.